All right, ladies and gentlemen. So let's real quick review for the the class that we did today. And today we're actually going to review on how to change from moles to grams and from grams to moles. So the first exercise that we're going to look at is saying that a chemist produced 11.9 grams of aluminum. So let me go ahead and text this down. It says a chemist produced 11.9 grams of aluminum. Let me 11.9. There you go. Grams of aluminum. Now the question is, how many moles of aluminum were produced? So now in this exercise, I have grams, and I want to go from grams to moles. In the previous video, we were explaining how to go from moles to grams, but here we're doing the opposite. So the first thing we want to do is set up a conversion factor. I have 11.9 grams of aluminum and we're going to go from grams to moles. So we're going to go from 1 mole of aluminum. Okay. So I was explaining in class that usually, and this is not a rule that is 100% set or is necessarily always true, but usually when we go from moles to grams, we usually multiply. When we're going from moles to grams, we usually multiply. Now, when we're going from grams to moles, like we're doing here, we divide. Now, 1 mole is, and we have to look for the atomic mass of aluminum, and we go to the periodic table for that, and the mass of aluminum is 26.98 grams. Okay, so again, almost always, or more in most cases, when we're going from grams to moles, we usually divide by the molar mass, and when we're going from moles to grams, we usually multiply by the molar mass. But again, it's always on a case-by-case basis, and of course, in this case, the molar mass is always the same as the atomic mass, which you find on the periodic table, and you always round to 2 decimal places. So we rounded to 26.98. And now what we have is that our units cancel out. So grams of aluminum cancels out with grams of aluminum. And then we basically multiply and make it a different color, or let me just spotlight it. What we're going to do is we're going to multiply 11.9 times 1 and divide that answer by 26.98. So basically, when you multiply 11.9 times 1, that equals 11.9 grams, and then we divide that. So again, we multiply 11.9 times 1, that would be 11.9 grams of aluminum over, actually 11.9 over 26.98. And when you divide that, the answer that you get is 0.441 moles of aluminum. Now remember, we're using 3 significant figures because whenever we're multiplying or dividing measurements, we round our answer to match the number of significant figures of the number with the smallest amount of significant figures. And I know that sounds like a tongue twister, but basically what I'm trying to say is that 26.98 has 4 significant figures and 11.9 has 3 significant figures. So that means that my answer is going to have 3 significant figures as well. This has 4 significant figures. This has 3. My answer is going to have 3. All I did is I multiply 11.9 times 1, which is 11.9, and then 11.9 divided by the atomic mass or the molar mass, which is 26.98, and that equals 0.441 moles of aluminum. Now, when we're working with moles and atoms, it's always good to understand that 1 mole, we use Avogadro's number, and 1 mole of any element, 1 mole of any element whatsoever, is always going to have 6.022, or is going to be assumed to have 6.022 times 10 to the power 23 atoms, which is, of course, Avogadro's number. Okay? And Avogadro's number, as I mentioned in class, is always a constant, and that means that it does not change. So whenever we're working with moles to atoms or atoms to moles or anything like that, we're always going to use Avogadro's number. Okay, so that being said, the second exercise, which is actually starts on page 82 of your textbook, or is on page 82, says, how many moles of silver are present in 3.021 times 10 to the power of 23 atoms of silver. 3.01 times 10 to the power of 23 atoms of silver. So again, we establish our conversion factor, and we're being given the atoms of silver, which are 3.021 times 10 to the power 23. So we're going to say 3.01 times 10 to the power 23 and again, atoms of silver. So I'm going to abbreviate to AT, atoms. Well, I was going to try to abbreviate, but I just wrote the whole word. Atoms of silver, and then to moles. Mole of Ag. So obviously, we know we have to cancel atoms of silver with atoms of silver. So we use Avogadro's number to cancel out the units, because remember, 1 mole of any element is assumed to contain 6.022 times 10 to the power 23 atoms, based on the investigations made from the Italian scientist Avogadro. So basically, we have our conversion factor, and this is 6.022 times 10 to the power of 23. And of course, that'll be 1 mole. So basically atoms of silver, which is here as well. And remember that the chemical symbol for silver is Ag. So basically, atoms of silver cancel out with atoms of silver. There you go. Atoms of silver. And then we're just going to divide. So you're basically going to multiply 3.01 times 10 to the power 23 over 1, which of course is the same number. Remember, identity property. So 3.01 times 10 to the power of 23 over 6.022 times 10 to the power of 23. Now, in this case, they both have the same base and the same exponent. That's not always going to be the case, but in this case, it was. And pretty much what's going to happen is that the exponents are going to cancel out. So basically, what the times 10 to the power of 23 is pretty much going to cancel out. So this pretty much cancels out. And then I have to divide 3.01 by 6.022. And remember that we're going to round our answer to significant figures, in this case to 3 significant figures, because 3.01 has 3 significant figures and 6.022 has 4. So basically our answer is going to be 0.500 moles of silver. And 500, because it's actually 499, so you round it to 500 and you add the other 2 significant zeros, because remember that any zero to the right of the decimal is significant. So this would be moles of aluminum. And what we're missing is just one last problem, which we are going to discuss now. And so that A can look better. All right, so basically, again, all I did was I canceled moles of or atoms of silver with atoms of silver, and I divided the number that I got by Avogadro's number, which was approximately 0.500. Now, the last exercise that we're going to do is on page 83 of your textbook, and the exercise or the problem reads, what is the mass in grams? What is the mass in grams of 1.20 times 10 to the power of 8 atoms? What is the grams in mass of 1.20 times 10 to the power of 8 atoms of copper? Which is Cu. So here, I actually want to go from atoms to moles. I want to go from atoms, because I'm getting 1.20 times 10 to the power of 8 atoms, and I want to go to grams. So we're going to go first convert. We cannot go directly from atoms to grams. So that means we have to stop, make a little bit of a pit stop, and we have to actually convert our atoms of copper into moles of copper. So 1.20 times 10 to the power of 8 moles of copper. So moles, or excuse me, not moles, atoms of copper. We have to go from atoms to moles of copper. And if I'm going from atoms to moles, I have to use Avogadro's number. I have to use Avogadro's number because we established that 1 mole of any element is going to be approximately 6.022 times 10 to the power of 23 atoms. So Avogadro's number is a constant, and it means it never changes based on all the scientific evidence. If it did change, then that means that there must have been a lot of scientific evidence to change that. But for the time being, that is what Avogadro's number is. It remains unchanged until this day. 6.022 times 10 to the power of 23 atoms. Right? So atoms of copper. And again, we basically need a calculator, and we have to pretty much multiply 1.20 times 10 to the power of 8 by 1, which is, and let me just finish writing this. so that way I can illustrate what I mean. So 1 mole of copper contains 6.023 times 0.22 times 10 to the power 23 atoms. So the first thing that's going to happen is that the atoms of copper are going to cancel out with the atoms of copper, which means that my answer is automatically going to be given to me in moles. After that, I'm going to multiply 1.20 times 10 to the power of 8 by 1 and divide my answer by 6.022 times 10 to the power 23. So you obviously need a calculator for this. You need a scientific calculator. And basically, you have 1.20 times 10 to the power of 8 and you're going to divide that by 6.022, excuse me, 6.022 times 10 to the power of 23. Now remember, significant figures are very important, especially when you're working with scientific notation exercises. So you're going to divide this, and I need my answer in I need my answer to have three significant figures. Okay. So I have 1.99, 1.20, and 6.022. So obviously I need to write my answer in terms of three significant figures. And that would be 1.99 times 10 to the power of negative 16. So I just round that up to 2. And I write it as 2.00 times 10 to the power of negative 16 moles of copper. Now, I'm not done yet because I want to go from moles to grams. So I just went from atoms to moles. Okay, so I'm going to go ahead and box this answer in. Now I'm going to use a different color so that we understand what we're doing. Okay, so moles of copper. And again, I'm going to box this answer in right here. So this is the mole of copper. Now that I have my mole of copper, I can change the mole of copper to grams. So whenever you're being asked to go from atoms of an element to grams of that same element, you have to go from atoms to moles and then from moles to grams. So now I'm going to go ahead and just, first of all, move this over here so I can have some space. And now I'm gonna go from moles to grams. So basically I have 2 times 10 to the power of negative 16 moles of copper, which is what I got. And I'm going to turn that into grams of copper. Okay. Now, in order for me to change that into grams of copper, I need to go to the periodic table and see what the mass in grams of copper is. Remember that the molar mass is numerically equal to the atomic mass. So basically, when you go to the periodic table, you find out that the molar mass of copper is approximately 63.58, if I'm not mistaken. 63.55. So if you go to the periodic table and you look for the atomic mass of copper, it's 63.55. Now I'm going from moles of copper to grams of copper, and this number is in the periodic table, is the atomic number, which is usually located beneath the chemical symbol, at some point beneath the chemical symbol, and you can make reference to the periodic table that is it at the end of your textbook. So mole of copper. So 1 mole of copper is approximately, and you're going to multiply that. So remember to leave our answer at 3 significant figures. So this cancels out. And this cancels out, and you multiply. And you multiply 2.00 times 10 to the power of negative 16 times 63.55, and that would be approximately 1.27 times 10 to the power of negative 14 grams. So that's a really small number. 1.27 times 10 to the power of negative 14 grams. So these are basically the last exercises for section 3.3, counting atoms. Hopefully this will help you guys understand a little bit of what was discussed today in class, and will also help you with the exercises that you guys need to do. So stay safe, and we'll see each other in our next class. So bye-bye.